And let's talk about another interesting topic, which is your multicast, right? So what we have here, we have one green cloud, and most of the time this cloud represent a subnet, right? And this cloud is representing this subnet right here, which is 192.168.10.0. We all know that inside this network we are going to have 256 hosts, right? And this is the first number which is representing the network number. And now we are having 6 hosts which is connected to a switch. Most of the time we are going to learn multicast from layer 2 perspective, right? So we have 6 different hosts. Maybe this is host A, this is host B, this is host C, then D, then E, and last is the F. It is assigned with an IP address. Here you have .10, here you have .20, maybe .30 here, .40 here, .50 here, and .60 here. You can understand. I have written down only the last octet, and because this is the part of this network, so you can calculate what are going to be the starting 3 octets, right? In terms of MAC address, we can say this guy is having A colon A colon A. This guy is having B colon B colon B. It is as simple as that, right? No issues, no problems. We all know about it. And if host A wants to communicate to host B, because these are part of the same network, they can talk. But before that, address resolution protocol is going to happen, right? Suppose in a case that address resolution portion is done. Now what is going to happen? At and we are presuming a scenario in which A is talking to B, and when A talks to B, what is going to happen, right? It is going to put its source IP address, which is .10, and I'm talking about the IP packet. You all know about it. The destination is going to be .20, and if this guy needs to send this packet over this wire, you all know that we need to create source MAC and destination MAC. As I mentioned, suppose ARP is already done for the MAC address for the IP address .20. So this host knows about it. This host know what exactly the MAC address of B, because ARP is done or the resolution process is done. So it is going to put destination MAC address as B colon B colon B, and the source address it is going to be A colon A colon A. And because of that ARP packet exchanges, the switch understand that on its 0/1 port, A is connected, or the A colon A is connected, and on its 0/2 port, B colon B is connected to. So this guy can straight away send the packet to the switch, and switch will be forwarding it right here, right? Such communications in which a particular host here in case .10 is straight away talking to .20, there is a one-to-one communication. A is communicating with B, and we call such communication as unicast. You all know about it, right? But let's talk about the ARP message which happened before this, right? What was that message? Again, we have an IP packet which is having .10 here, .20 here. No problem. This was my IP packet, right? But at that point of moment, I didn't know about .20. So what I did an ARP, right? And that I created first of all that ARP message, and you know what is going to be there in the ARP message: sender MAC, sender IP, target MAC, target IP. I'm not going to write them again, but you can understand the target IP is going to be .20. And if you want to send this ARP request message over this white wires, which are your Ethernet wires, then you need to put this L2 header, and there you are going to write the source, which is A colon A colon A, and the destination is going to be all F. And I have programmed this switch that whenever you receive F colon F colon F as a destination address, Your job is to forward this frame to all of your connected interfaces except the one on which this frame had been received. So it is going to be forwarded here, 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 everywhere, and not here, because you understand, because the frame is received on this port, and you all know about it. It means that switch is capable of sending this message to everybody, right? Such communication are known as broadcast. So we understand unicast, we understand broadcast till now. There is a separate category now. And what is that category? Suppose now you do not want to do one-to-one communication. No, A doesn't want to talk to B. And you do not want to have the broadcast communication, means A does not want to send the message to everybody, means B, C, D, E, and F, right? A actually wants to send the message to F, E, and D, right? So if I make a circle around these ports here, F, E, and D, now this is a specific group out of 6, right? So previously there was a group of 6 hosts, A, B, C, D, E, and F. Now what you are doing is you are creating a particular group out of them, right? A wants to talk to this group. A does not want that this message should go to B and C, right? So now you are communicating, or your source or your host is communicating to a group of hosts, not the single one, right? You can argue with me that in case of broadcast also this was happening, because in that case the group was the complete A, B, C, D, E, and F. And your analogy or your thinking is absolutely correct. I am talking about groups here. Broadcast was also a group, right, of all the hosts. But now, can I have something lesser than that? Because there might be the case in which this host, if suppose host A is sending some video traffic, and that video contains some sensitive information, it does not want that B and C should receive, that only wants F, E, and D should receive. And this happens, right? Suppose your company's CEO or your vice president have some important message to say. What they generally do, they come to a single room, which is your source, and they create a video, and then that real-time video is distributed to you, right? Generally, what you do, you open your laptop, somebody has sent you the link that if you want to join Mr. CEO conversation, you need to click on this link, and whenever you click this link, that video will be delivered to you. And of course, if somebody is not having that link, he cannot listen to all these videos because he cannot tune into it, right? So there are 3 types of communication. You understand unicast well, you understand broadcast well, and now here is the thing. We are talking about multicast, which where you want to send the message to a group of people, right? And here is my problem. The problem is, suppose it is happening at the layer 2 level, right? Or suppose, let's draw the packet. Here, source A or host A wants to send the packet to D, E, and F, right? What is going to happen, guys? The source IP address, I am pretty confident you all know. The source IP address is going to be host 10 address. And here is my problem. What should be the destination IP address, right? Whether it's an IP address of F, it should not be, right? Because I want to send the packet to E also, to D also, right? So I cannot put a simple unicast IP address and IP header. Just give me permission to only hold only one IP address, right? I cannot say that I want to send this packet to dot 60, dot 50 and dot 40. I cannot put three IP addresses in the destination field, right? It means that I need some more or something else apart than unicast routing, right? So that I can send this packet to these hosts. Similarly, this problem is going to be there at layer 2 level also, right? You are going to be pretty sure about it that the source MAC address is going to be a colon a colon a because my source is this one which is sending the continuous stream of video, right? What is going to be my destination? Shall I put MAC address of dot 60 or F? Shall I put a MAC address of 50 or 40? What should I put it here? Or shall I put all the MAC addresses in this field? Which I cannot do that because my Ethernet header has only one destination MAC address. I cannot put three. It means that at L2 level also, I need some specialized addressing, right? Just take a clue from the broadcast. What do we write if you want to send the broadcast message at the layer 2 level? We write F colon F colon F, and we have programmed this switch that if you get F colon F, basically you need to forward it to, but we cannot do that, right? Now it is not broadcast. We need to think some other addressing scheme. And believe me, before coming to that addressing scheme, I want to give you this analogy because here one source is trying to send messages to three different hosts. It means that this is not the unicast communication. This is not the broadcast communication. This is the communication where you are selecting a group of hosts and want to send the message to that group of hosts. We call such communication as multicast, and there is a completely different routing for multicast. And believe me, if you know only unicast routing and if you try to understand multicast, because multicast approach is totally different, right? People have hard time to understand multicast. But if you have this board or upcoming two or three boards in your mind, understanding multicast is going to be very easy for you, right? Because we have absolutely started from scratch. Why do we need it? And from this board, you should understand the why behind multicast. If you haven't, let's take an analogy of frequency modulation or FM, right? We all hear FM. But to hear that FM, we need to tune our radios or music system to a particular frequency. If you don't get it, what I said in my last statement, let's talk about it. Let's spend some more time understanding this multicast, right? With an interesting analogy here. So what I have done here is that this is my medium or basically air, right? And here I have my FM radio office. What is the meaning of FM radio office? Generally, a guy sits here and he talks to everybody and he plays some music, right? But he makes sure that whatever he's talking or playing or whatever the program he's doing, right? He send this program at a particular frequency. And if you are from India, India have different such frequencies which you know, and there is one pretty common, pretty popular in India, which is 93.5 megahertz, which you say that if you this is a particular 93.5 megahertz frequency at which this FM radio presenter is sending the messages, right? So this is a source. This is my source. It is transmitting this message into this air at a particular frequency, which is 93.5. So we are done with the source part. Source is done with the duty that it is, suppose at morning 8 a.m. this program start. So this guy comes and start speaking, playing the videos, or sorry, playing the audio song, and it is sending or transmitting this onto this air at a particular frequency, which is 93.5. As simple as that. Now consider a guy here which is sitting inside his car and he tuned to that frequency, which is 93.5. What is the meaning of tuning? The meaning of tuning is this guy is instructing the music system or the radio to listen at this 93.5 frequency so that anybody who is sending the messages at 93.5 can listen this, right? Similarly, this guy who is sitting in his home has this radio, want to hear this program. This program is pretty famous. He is again tuned himself at 93.5 and he also gets the stream, the audio stream. Similarly, this guy also, right? But what is the step you need to do for it? You need to make sure that your radio is tuned, your radio start listening at 93.5 megahertz frequency, right? Consider these two guys, this one and this one. Although this program is pretty popularized in India at 8 a.m. in the morning, it doesn't mean that everybody is going to listen to it, right? Maybe this guy doesn't like that program at all. He's saying, I won't tune it to 93.5 because I do not like it. I like 98.5 FM or this frequency or the program at this frequency. So believe me, there's another guy sitting in this studio who is the owner or basically who is the presenter for 98.5, and it can present or it can send at this frequency, which is 98.5. And now the second frequency is going to be with this and towards this. And of course, although 93.5 is accessible here, but this guy is not tuned to 93.5, and that is why it is not getting the red stream. It is only getting the yellow stream, and you know the reason for it, right? So what exactly happening? Although we call frequency modulation or FM as a broadcast, but don't you think it's an example of multicast? Because right now we are sending our stream to a group of people who are listening at this particular frequency, right? Interesting. This is what we explained in the last board. If you consider these as hosts, right? We want to send this message at this particular frequency instead of frequency. Basically, in computer networks in IP, they have come up with a different range of IP addresses. You must be wondering what is the range now, right? So if I give you a clear idea about the IP addresses from 0.0.0.0 to 223.255.255.255, this entire range from 0 to this guy is your unicast range. I have specifically, or TCP/IP developer has specifically informed these switches routers that basically this is your unicast range. So it has a meaning of it. If I take an IP address out of this range, suppose 2.2.2.2, this actually uniquely identify a host on the internet. It is as simple as that. But when we talk about a specific range which starts from 224.0.0.0, which is the next IP address after this IP address, right, till 239.255.255.255, this is basically a special IP address range. And if I take an IP address out of this, maybe 225.10.20 20.1. Suppose this is the range from this IP address, and now TCP/IP developers has defined that this is not uniquely identify a one host. On the contrary, this address can mean multiple hosts. What are those hosts? We are going to see that, right? For example, right here, if you can see the analogy, if this device is listening as 93.5, it doesn't mean that only this and this device can listen. Anybody which is having this frequency or which is tuning to this frequency can hear that, can hear the audio stream by the source, right? Similarly, I'm saying that anybody who is having this IP address, right, which is a specialized IP address, can listen to the stream sent on this address. So if you have this board in your mind, multicast is easy to understand at the layer 3 as well as layer 2 level. But to listen 93.5, you have to do an extra effort. What is that effort? You go to your music system, you tune it to a 93.5. Similarly, in case of IP host, if you want to hear a particular video at a particular IP address, right? You need to tune to this IP address. Which IP address? The new set of IP address, which is your multicast range. It is as simple as that. So from 0 to 223, it is your unicast range. The next from 224 to 239, it is going to be your multicast range. If you didn't get these ranges, we are going to talk about more. But let's try to understand one more thing, one more. We are going to have the same analogy, but this time we are going to learn it from our switched network, right? Because most of the time, the area of discussion is going to be layer 2, although we will be discussing some part of layer 3, but layer 3 multicast is a huge topics, guys. Maybe we can create a course on that, or maybe I can upload some of the videos on multicast if you want. But now let's consider we have a network here. The IP network is 192.168.1. Say 0/24. This host is having IP address .1, and suppose it's having MAC address of A:(A:). Simple. Similarly, this host maybe is your .10, this is .20, this is .30, and maybe this is .100, and this is .200. There is a specific reason that why I have marked the color of this host as yellow and this host as green, because what I want is I want to send message from this host, which is host A, to a group of people. And what are those group of people? These are those group of people. Host A wants to send the packet to .10, .20, and .30, which you might say that this is my, you guys just wait a minute. Yeah, sorry, so I lost my cursor, but now I get it back. So can anybody confirm that you can hear me?
Yes, Vishnu.
Yes, I can hear you.
Perfect,
Yes,
perfect,
Vishnu.
perfect. So maybe this host is your host B, this is C, this is D, and this is E, and that is F. And now you are only interested in sending the message from host A to 10, 20, 30, or basically BCD. It means that you are interested in multicast. Just have the previous analogy in your mind and just try to understand that unicast is not going anywhere. If this is a IP host, you have to assign the unicast address. So unicast address is right here. But now, interestingly, what this host is doing, it is sending its message. Suppose it wants to deliver a particular video stream to only these green hosts and not those yellow hosts. So what it is saying, it is having the source IP address of course, 192.168.1.1, and the destination, it is choosing a specialized IP address from the multicast range, which is 224.0.0.5. Interesting, right? This is, let's say this is your IP packet. I'm not talking about for some time what is going to happen uh, when you want to put the L2 header. Let's not talk about for it now. We will be talking about it. But let's say anyhow it gets reached to this switch. What? This IP packet. And IP packet is capable of sending it to it. Right? So a switch is capable of sending to this IP address. But interesting portion is I have sent something to these green devices, maybe a link, right? And that link is not sent to these devices, the yellow devices. And what these guys are doing, because I am only interested in sending this information or the video stream to green guys, right? So whenever they click on that link, interestingly, they previously had this IP address of course .10.20.30, but when they click on the link, their NIC or their network interface card, which was previously assigned an IP address of .10, it got started listening at 224.0.0.5. It doesn't mean that .10 is going anywhere. No, .10 IP address is there. But along with .10, when we click on that link, this NIC has another IP address, which is 224.0.0.5, right? Interesting, right? It is having two IP address, one from the unicast range, one from the multicast range, and it can happen. Similarly, this guy, when that click on that link, because he is also interested in receiving that stream, it is having .20 IP address, which was previously assigned, and now it is also listening at 224.0.5. Similarly, D is doing that the same thing, but E and F cannot do that because these guys don't get the link. They do not know at which address to listen. And interestingly, this device is actually sending these packets to this port, and this port. And of course, you can understand this packet reach here, the IP packet, right? And on the basis of that, it basically, maybe this could be a router also, because we are not discussing the layer 2 portion, which I am going to discuss now. But it is fully capable of sending this to this guy, and this guy. This is the same analogy, right? But what is going to happen at L2 level, right? The source is going to be simple. It is going to be the A colon A colon A. What should be the destination MAC, right? So we have a complete range for IP for multicast, which is from 224 to 239. Last address you can calculate 255.255, and the starting address you can also calculate, right? Similarly, there is a MAC address corresponding to these multicast address, and you can calculate an MAC address from its IP address, or MAC multicast address from IP multicast address. You do not need to do address resolution for it. For example, if you have an IP address which is 224.0.0.5, this is your multicast address, right? You can calculate MAC multicast address also from it. You can argue with me, Mr. Vishnu, that MAC address is of 48-bit long, but the IP address is 32-bit. How can I generate a similar number from this to this? And there are some rules that the starting 24 bits should be 01, 00, and 5e, and the remaining 24 bits you can take from this IP addresses, right? But this is interesting to convert from multicast to MAC address, but we are not learning this to that detail. But you can think in terms of that every multicast address is going to have the MAC address, so you can calculate it. So that MAC address is going to be here. We are going to understand this thing in next board. So now you do not need to do an ARP for this, because what is the functionality of ARP? ARP can give you MAC corresponding to an IP address, right? But here you have specialized IP address, which is 224.0.0.5, and through mathematics you can calculate the MAC address, which should be starting from 01 something 00 or something, right? And interestingly, this device, when it starts listening at 224.0.0.5, this is the IP at which it is listening. What is the MAC at which it is listening? The MAC address is corresponding to this multicast address, which is going to start from 01, 000, whatever we have calculated. Does it mean that it is not going to have its own MAC address? No, that is the unicast MAC address that was there, right? Previously with .10, maybe that that MAC address is B colon B colon B. That was there. But now when it starts listening at 224.0.0.5, it starts also listening at this multicast MAC. It means that if this switch is multicast aware, and to make this switch as multicast aware, we need to configure few things which I do not want to explain here. The switch is going to create some entries into its table which are corresponding to this MAC addresses. So it could be the possible case that basically this switch can be sending on the basis of this multicast MAC address. And it knows that this multicast MAC address is attached to this host, and this host, or this port, and this port. It is going to send the multicast frame out of this guy, and this guy, and it won't send it over here. No, over here, because multicast MAC is not here, because these guys are not listening at 224.0.0.5. Having said that, I know that there are going to be a lot of questions on it, but that is perfectly fine. We will deal with the questions, no issues. But let me complete first the last board, which says, what does it mean when I say that I am listening at 224.0.0.5? This is very important. And this is one of my green hosts, right? So host A was sending multicast stream to green host, and I'm saying that this green host is click on that link, and now it is started listening at 224.0.0.5, which is a specialized IP address or multicast address. So what is the meaning of it? The meaning of it is, suppose this guy has .10 IP address, and this guy has, sorry, .20 IP address, and this guy has the MAC address B colon B colon B. I'm talking about unicast now. When it start listening on 224.0.0.5, it is configured with this IP address 2.224.0.0.5. When did you configure? If you click on that link, the NIC of this laptop, which is having .20, it also start listen to this communication, just like 93.5 FM. When you tune your radio into this, it start listening at 93.5. Similarly, when you tune your NIC for that multicast stream or the video stream from the source A, this laptop is going to start listening at this IP address, which is 224.0.0.5. Simple, right? Also, at layer 2, it start listening at the MAC address also, which is starting from 01, 0E, and 5E. Right? The last, I think I have done some calculation mistakes. So right now, suppose you are listening at 224.0.0.5, right, which is the specialized MAC address, sorry, IP address. You can create the multicast MAC address out of it, right? So when you click on that link of the video stream, your green host, which was listening, which was configured for .20 B colon B colon B a unicast address, it start listening at this also. It is as simple as that, right? So a host can have both unicast and multicast IP address, which you can see. This is the unicast IP address. This is the multicast IP address. A host can have both unicast MAC address as well as multicast MAC address. As simple as that. But what are going to be changes in the switch? Suppose there is a switch here. Again, one host is here. One host is here. But we are interested in sending the stream to these three specialized people. And the stream is coming from this red host, right? So what this host is going to do, it is going to say, I'm talking about L2 more now, right? So I'm drawing only L2 frame. So this was my IP packet, maybe the video packet which is generated by this source. It is going to send them onto this green, right? So let's talk about what is going to happen at the layer 2. The layer 2 source IP address is going to be the MAC address of this source A colon A colon A, and the destination MAC address, because we are more interested in layer 2 multicast, because this is the point, right, which we are going to discuss how it is going to be delivered. The destination is going to be, suppose we are sending at 225.4.0.0.5, which is multicast address. So the system is going to calculate the MAC address, which is this MAC address. Suppose this is X now. I want to write it down. I cannot fit the complete address here. So I'm writing here. But from this X, you can understand I'm talking about this one. This packet is going to, this frame is going to reach to this switch. And interestingly, this switch is multicast aware. If I say that this switch is multicast aware, the meaning is that this switch can understand the MAC multicast, and it understands that now we are talking about the group of hosts. We are not talking about a unicast, right? How we can make a switch multicast aware? There are some protocols which can, like CGMP, Cisco Gateway Management Protocol, or IGMP, Internet Gateway Management Protocol, right? If you configure those on this switch can understand, and basically it can create a table in which now the there might be some entries like port 0/2 is connected to this multicast address X, 0/3 is also connected to this multicast address X, and 0/4 is also connected to this multicast address X. It means that when this packet reaches at this switch is going to replicate this packet on 0/2 interface, 0/3 interface, and 0/4 interface. Why? Because these devices are listening at this IP address 224.0.0.5, means they are listening at this MAC address too. And that is how switch learns about it through these some protocols which we do not want to learn now. But try to understand this switch is fully capable of doing the multicast routing. But what if you haven't configured this CGMP or IGMP? What switch is going to do with this multicast address then? If you do not, if your switch is not multicast aware, and most of the times our switch is not going to be multicast aware, and if that is the case, there are only two possibilities. The first possibility is this switch does not understand the type of multicast address and it drops the packet, right? Because it is not going to see the entry in the CAM table. Or we can program this switch that whenever you receive a multicast address, you need to treat it as a broadcast. It means that if it gets it, and if it is not multicast aware, it is going to send it to here, 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 and here. So instead of dropping the packet, you are sending it to everybody, and that is going to happen in normal switching case. But how switch is going to identify that this address is this particular address is my multicast address? So believe me, this MAC address is actually of 48 bit, and the 8th bit from the start is actually your individual or group bit. If this individual bit is 0, it means that this is a unicast address, If this bit is 1, it means that this is the group address. And what is the meaning of group? Group means basically we are talking about multicast here, right? And that is why this number is in hexadecimal notation. So one number is of 4 bits, and that is why basically if one number is of 4 bit, then 0 means 00000, 1 means 0001. So the eighth bit which you are seeing here is set 1. It means that the I/G bit is 1 here, which proves that this is the multicast address. Once it sees that this is a multicast address, it has two options: whether the switch is multicast aware. If it is, then it is going to send on the respected port. If it is not, then it is going to send it to everybody, or it is going to say this is my it is going to treat it as a broadcast address. It is as simple as that, right? So I just want to finish on a note here. Can I safely say that multicast is a type of broadcast, or vice versa? If I can say broadcast is just a specialized case of multicast. And believe me, the second statement makes more sense. And the reason is what did I say? I say broadcast is a special case of multicast is making more sense. Why? Because what is multicast? Multicast is a group. Suppose we have 6 hosts, 1, 2, 3, 4, 5, 6. If I want to send the packet to 4, 5, 6, this is one group, and we are calling it as a multicast. What if I want to send a packet to complete group? This was your broadcast, but this is a specialized case of multicast in which you have included all the hosts. It is as simple as that, right? Maybe too much of information. Maybe if you understand it, it is easy for you. But believe me, if you watch this video again, if some confusion is there, just see this video, because we are going to use this. Whenever I say that OSPF is sending their updates to 224.0.0.5, you should understand that basically it is sending this to a specialized group, not to everybody, right? Having said that, this is what I had to cover in today's class. Now I am open